Alright, people. It is time for another episode of Let's Build a Compile Time Evaluation. What's the word? Compile time function evaluation engine or implementation. Well, okay. I hope you're all fired up. I'm fired up. And let's get started. First off, what do I want to do right now? Well, I had a few problems regarding function calls after I introduced a new way to generate parameters. And you may ask, why would you want a special API to generate parameters when it is just the first 4 bytes on the stack from the current stack pointer? Well, the answer is this. Let me, do I have it loaded? No. The answer is this. This BC test function. This stuff here. Okay. As you can see here, when I write this function by hand, I can say p1 parameter 1 is the BC value of stack address 4 and it has the type i32, which is the only supported type right now. When I write those functions by hand, this is all fine and dandy. But if I use like my function printer, whose output looks like this, how do I know that this thing here is a parameter? I don't know that this thing is a parameter. I have no idea. Right? Yeah, and this thing was generated by the wrong version of the printer. You can see this by having those values. All stack addresses have they have to be multiples of 4. Well, yeah, you can see here it is impossible to see what am I working with, right? So I have to have a way to make a call to generate the parameter so the printer knows that we indeed want a parameter. And I implemented this, but I made a big mistake. Here in BC Common, where the common stuff for all the bytecode is, you can see I take the parameter and I set its parameter value. But what I don't do is setting its stack address, which will cause it to refer to stack address 0. Every parameter will refer there. Yeah, and this basically breaks everything. So, thing we have to do is to pass in a stack address. Into here when we generate the parameter. This means we need to store the stack address on the BC parameter. BCP. Here. Let me just very quickly add this. We start the parameter offset in there. And in theory we could compute the parameter offset. But let's not do this for reasons that will become visible later. Now we need to change our genParamter call to take a stack address. Our second parameter. Now let's implement this in all our implementation. This inksp was bogus, you will soon see why. Basically it leads to recursive behavior when we print our calls out. And in the C backend we have to do the same. I think this should do it. No, wait. We don't have to do the stack offset. If we can use the stack pointer. There we go. This is how it should be implemented. It can be implemented the same in bc.d. And now we have to make the call correct in PC common again, because we don't take the stack address after all. Okay. Now let's see if this works. Yeah, and CTFE BC is now no longer supposed to do that. And maybe I'll change that later. Yeah, and it is not supposed to increment the stack pointer either. And we still have the same problem. We try to get something from stack pointer 0. This is very bad. What happens when I do this? Then it shouldn't compile. Yeah, and it doesn't. So this variable seems to point to stack pointer 0 all the time. The parameter variable. This here is an honest to god local. Second local. Third local. But you never see the stack pointer 4, which should be where stack pointer 0 is right now. And this is because the genParameter call does not return the correct value. So let's see what is going on here. Parameter takes the parameter count and the current stack pointer as BC parameter and creates a BC value from that. And if BC common does the right thing, it should in its constructor set the stack offset, but it doesn't. So let's now do this. We now set the P offset, and now we should be good to go. And we no longer crash. It works. Isn't that great? Now that that works, we can use our printing backend to change that into a test. The way we do that is we go in here, go up, oops, and there we have our choices of what backend to use. First, let's use C backend to make sure that the code the C backend generates is fine. And this does not look fine to me. Not at all, I'm afraid. So the C backend definitely has a few problems. As far as I can see. Okay, now let's use the printer backend to see what calls to the BC generator are generated. Whoops. Of course, we gotta recompile. There's a P1 genParameter. The parameter is of type car. That's correct. This curse stack pointer in stack pointer has nothing to do with the parameter and everything to do with allocating that local. And maybe I should actually call it allocate local or something. So all those stack address things would then change into local 1, local 2, blah 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 blah. And that would probably be the better way to go. So if the printer works correctly, when I copy this code and I put it into BC test where this code was before, and I remove all the stuff that is commented out, those are superfluous calls, by the way. Yeah, this is basically again jump, and we could replace it by that. Okay. This should now accurately represent our switch statement. We need to add a brace here. And now all those static asserts here should pass. Except for this one has to check for 2. And we have to make clean. Oops, make clean POSIX. Because this is a template and doesn't get recompiled on change. Okay. Apparently P1 is undefined. Huh. Because this never worked, the printer doesn't generate the correct call. The correct call would be to introduce P1 without a P1, but it doesn't because this never appeared in the printer output so far. We should fix this in the printer immediately. In the printer backend, genParameter. There we go. Oh yeah, and we haven't fixed our because it never worked before. Our things here. To use the other static asserts. Basically this. Now it should work. And apparently it doesn't. Because of... No, that should work. Does the first one fail? Yes, the first one fails. Okay, this is strange. Alright, we check if this is equal to that. This is what returns 5. It should return 5 when we pass A in there. If I'm correct. Let's open the function, the code from which we generated this. Yeah, A should return 5, and this is the most straightforward case. So let's actually check for that. And if that doesn't work, we have a serious bug. It generates the parameter, increments stack pointer afterwards to make sure to make space for the local variable at stack address 8. It initializes it to 0 then it checks if P1 equals 97. Which at this point it definitely should. Okay. If this is a problem with our genParameter call, then we can try replacing this with the manual version. And if this still fails, we know that we have a problem. That is not with the parameter. Static excerpt in 177 fails. This is the E1 here. This is probably something that changed. If I get E, I should break and return 16. That's still true. When I get 101, I will jump to whatever jump 6 jumps to. And conditional jump 6. Actually, no, that's not true. Let's use the C backend to find out what happens. And let's reintroduce the genParameter to see if it still fails at the same point. Yeah, it fails at the same point, which means that the other ones succeed. Even when I replace this with A again. Yes. So if I comment the E1 out, the rest should succeed. Is that true? For the BC gen, it succeeds. For the CBC gen, it does not. Which means that the CBC gen must have a problem here. But that was what we were going to debug all along. So let's see what the CBC gen generates. There we go. We change our use printer backend to use C backend. Recompile. We comment on the tests and then recompile. No. And now if we generate our test switch, we should see what's happening here that causes it to fail. Oh, that's the same problem which I remarked upon before. We are not using the parameter. So and this is because it gets the current stack pointer instead of getting the thing that's stored in the parameter. So with this change in place, we should get better results. This looks much more reasonable. So if we are lucky, our tests will compile. And BC test, there it is. We can now re-enable the static asserts. The one where we know it works. We gotta make clean. Recompile. And then we see if both backends pass the tests. And they both do. Now we can look in the C backend output. What is happening? That makes it fail on the other test. Okay, this should be done by a jump to label 14. We jump to label 14 if this condition is true. If we have 101. Let me check this. And let's see. So this is interesting. First, let's get rid of all the stack ADDR stuff and make it into local. Because I really cannot stand seeing those. Or, you know what? I am going to end this video here. And I'm going to make the next video about converting it into locals. Because now I'm going to debug something that's way more boring. It has to do with arithmetic. And I have to think a lot for that. So I can't make a video while doing it, or if I would do so, it would seriously impede my progress. And I wouldn't want that. And I'm sure you wouldn't want that too. So, see you all a bit later.